All right, Algebra 1, here we go, guys. We are in Section 5 today. So Chapter 8, Section 5, all about the Pythagorean theorem, okay? Pythagorean theorem, this is directly connected to right triangles, okay? So you're going to see everything that I've highlighted here. In fact, everything you're looking at on this screen, these are all of the notes. And then directly underneath this, we'll cover the example problems. But this is everything you're going to need. Everything that's highlighted. To be honest with you, you need it all, okay? So Pythagorean theorem only works with right triangles. What is a right triangle? Just a little review. It's a triangle with a 90-degree angle. What does a triangle with a 90-degree angle look like? This right here. This is a triangle. And then right here, that's the 90-degree angle. So it makes a box shape, okay? And only a right triangle will connect directly to the Pythagorean theorem, okay? So you may get a triangle that doesn't look like a right triangle, but what if we could cut it in half? Then it might look like a right triangle. And you'll see an example problem where we do one of those, okay? So this info right here, you will need to copy that down, okay? This is the Pythagorean theorem. This is the equation right here, all right? So let's do a little zoom in. The Pythagorean equation, a squared plus b squared equals c squared, okay? And then where do we get that info? Where is a, b, and c in relation to the triangle? This is it right here, okay? A is considered to be one of the legs, so is b. A and b are actually interchangeable. Like you could switch their locations in the equation, like b could go here and a could go here, and that doesn't change it because they're both on the same side. But what you really have to make sure is that the c value is always over by itself. C goes with the hypotenuse. And why is the hypotenuse the most important side? Because the hypotenuse is the longest side. All right, and the longest side, if you never see where the right angle is, being right here, find the longest side, and it's always opposite. Or if you know where the 90-degree angle is, go opposite the 90-degree angle, and you will automatically know that is the longest side. Okay, so that is a helpful tool if the 90-degree angle is given, which it always should be. Opposite will be the hypotenuse. Why is it special? It's the longest side. All right, I know I'm repeating myself because you need to remember this important information. All right, very important. Okay, and then let's zoom in right there. You will need this info. This talks about how you can change the order of A and B. You could put B squared plus A squared, but you can never move the value of C. That must always be by itself. All right, let's do some example problems. Okay, so we need to find side C. We didn't even need to have a picture here. They're going to give us A and they're going to give us B. All right, so let's remember the equation. A squared plus b squared equals c squared. That is our Pythagorean equation. Let's plug the values in, all right? Here's A. We're going to plug that in right there. There's B. We're going to plug that in right there, and we will be solving for C. All right? Now, let's do that. So we have 5 squared plus 12 squared equals c squared. Notice you have to still have those squareds there. They don't just magically disappear, okay? Now, let's simplify this. What is 5 squared? 25. What is 12 squared? That is 144. And then that is still equal to c squared. All right, simplify it one step further here. 169 equals c squared. So 25 plus 144 is 169. We're not done yet. They want to find c. What do we still have? We still have c squared. We're not done yet. How do you get rid of something that says squared? What's the opposite of a squared? This is important information. The opposite of a squared is the square root. We want to get rid of that squared, so we need to take the square root. And what you do to one side, you must do to the other. So that means we now will have c alone. It's by itself. And this is where it's really going to come in handy if you have all of those perfect roots memorized from 1 to 20. 1 times 1, 2 times 2, 3 times 3, all the way up to 20, because you will actually now know that 169 is 13 times 13, which means the square root of 169 is 13. There we go. All right, so that's number 1. That's example problem 1. Example problem number 2. All right, so they give us C, they give us B, they don't give us A. So the order, actually the steps will change just a little bit. All right, the order is all still the same. You still have A and B and C. It's just that we have A squared plus 15 squared equals 17 squared. Okay, and let's see. All right, we'll get our numbers all lined up here. A squared plus, and then 15 squared is 225, and 17 squared is 289. Okay, and now what we're looking at is we have to get a squared by itself. Okay, so we need to get that 225 away. We need that to disappear. How do we do that? We now need to subtract it. So it disappears here. And then we need to subtract it right there. So what we have left is a squared equals 64. This is working out very nicely because 64 is a perfect root. And as we learned in the last problem, how do we get rid of a square? Because remember, they want a. They don't want a squared. They want just a. So we have to take the square root of both sides to get rid of the square. So that's going to leave us with a equals 8. Okay. All right, let's make sure we're keeping up. You guys are watching these note videos and taking notes as we go. Okay? All right. Let's do example problem number 3. This is the one I wanted you to see where it doesn't necessarily start looking like a right triangle, but we cut it right down the middle. Okay? We cut it right down the middle, and what you're going to notice is here's our A, here's our B, and here's our C, right? When you take a look at a right triangle, here's the right angle right here. All right? So they didn't put it in there, but if we cut it off right there, that is our right angle, which means this could be A, this could be B, and always opposite the right angle. If we go opposite the right angle, we will then land on C, the hypotenuse. Okay, so let's set this up so we can solve for x. We're going to have 5 squared plus b squared equals 13 squared. Remember, though, I said that a and b are interchangeable. So if you wanted to treat x as if it were a, that's fine. You're still going to get the same answer I'm going to get. We're just solving for x. All right, so you just need to designate it as it's either a or b. It doesn't matter. It could be either one. Okay, so now we have 5 squared is 25 plus b squared equals 13 squared, which is 169. Then we need to subtract 25 from both sides, so these guys will cross out. B squared equals 144. And again, I gotta make sure you understand how important it is to really remember your perfect roots from 1 to 20. All right, it's just going to make these types of problems easier so that you can quickly know, all right, these are perfect roots. 144 works out perfectly. Take the square root. Why do we do that? Because of this guy right here. We need to get rid of the square by taking the square root. When we do that, that crosses out, leaving just b by itself. And the square root of 144 is 12. All right. Last problem. They're giving us all three pieces. Tell me if the three given sides would actually make a right triangle. Now you may ask yourself, well, I don't know what's what. I don't know what A is, what B is, or C is. Don't forget, the biggest number is always the hypotenuse. The biggest number is always C. That means that the other two are A and B, and remember that I said A and B are interchangeable. Doesn't matter what you call A or B, they're the two smaller numbers. The biggest number is C. All right, so let's write this out. 8 squared plus 16 squared equals 18 squared. We are trying to say if this works, like yes, this works, or no, this doesn't work. If the answer is yes, it's a right triangle. If the answer is no, it's not a right triangle. All right, so we need to figure this out. We have 8 squared is 64. 16 squared is 256. And 18 squared is 324. We are trying to figure out if this is a true statement. Is 64 plus 256 equal to 324? When we do this math right here, you get 320, and they're saying it should have been 324. So that is not equal. It does not make a right triangle. So no, not a right triangle. Here's the proof right here to justify my answer. All right. There we go. Let's do a quick zoom out so you guys can see everything right there. All 4 example problems from section 5. All right. Ask questions if you got them. I will see you guys in the next video.